So hello dear students. So in this particular video, we are going to discuss the second chapter in the physics course of 11th class, and that is an introduction to one-dimensional motion. And a one-dimensional motion basically is a kind of motion which is taking place in a straight line. So in the first video, we are going to discuss only uniform motion, that is a motion with constant velocity and no acceleration. And in the next video, we will cover acceleration in one dimension. So these would be the two chapters related to the motion in one dimension. And we will discuss few elementary and important physical quantities related with this type of motion. And those quantities would give us, when we find out the relative relations between those quantities, we will find the predictive power of physics. That is how physics can predict the course of events by using simple equations and quantities, and those relationships between different quantities gives a predictive power to physics, so that physics can predict the future of an event or what is going to happen in the event given the initial conditions and what is the kind of the system that we are dealing with. So the first system that we are going to deal with would be a system in which no acceleration is taking place, and that system is the system in which the body is moving in one dimension, that is in a straight line. So that is the most basic type of motion that we can discuss to start with. So let us start what we call a one-dimensional motion, and in that we will first of all discuss the position and the frames of references. So to understand the position, we require the understanding of a frame of reference. So that is, what is the coordinate frame of reference? What is the basic reference mode, and according to which we are defining certain physical quantities like position and velocity. So you know that every object has got its own frame of reference. So you can say that, let us say I'm standing here and the position of a certain object with respect to me is 5 meters, but another person standing somewhere else will measure the position of the same object in a different way, and the value that he will ascribe to that position would be different. So that individual has a different frame of reference and I have a different frame of reference. So similarly, if you are moving and you are at rest, and in each case you are actually, in the two cases, you are actually measuring the speed of a train. So if you are moving in a car, depending upon the speed of the speed of the train will look faster to you or slower to you as compared to a person who's sitting on the platform and looking at the train in a stationary mode. So it's again a difference in the frame of references. So first of all, we should know that each person has a unique frame of reference, and all those frame of references will give us a different value of the same physical quantity. Although the physical event, the course of the event, and all the whatever is happening, the process, physical process that is happening inside a system, that does not change when we change the frame of reference. That remains the same, but the values that we ascribe to different physical quantities depend upon the reference frame that we are using. So let us start. So let us start about what is one-dimensional motion. So the simplest kind of motion that we can talk about is a one-dimensional motion. As I've already talked earlier, it is also called rectilinear motion. Basically, rectilinear means in a straight line. So it is a motion in which an object is moving in a straight line. So first of all, we have to define an object. So an object can be a point mass, something like a particle like an electron, so which is point in its nature. So it has got no dimension, and the motion of that point object would be considered that our object is moving with a motion described by a point object. But there are certain extended objects also which can be treated as point objects. Like for example, there is a block of say some mass or some brick is there, and that brick is moving over the surface. So the relative constituents of that brick, the relative members of the or the portions of the bricks are not moving with respect to each other. So a brick is a rigid object. So what is moving? Let us the front of the brick is moving at the same velocity as the front of the or the back of the brick. So all the particles of the brick are moving at a uniform motion. They are all having the similar kind of uniform motion. So then we can say that that brick is basically a point object, because there is no relative motion within the internal constituents of the brick. But let us say if some, let us say some object is tumbling, some flexible object is tumbling over the slide. Let us say a flower or some other thing is tumbling over the slide. So all the points of that object are also in the relative motion with respect to each other. It's a flexible object. So in that case, the motion cannot be described as a motion of a point object. So first of all, we should define an object, whether it is a point object or not. Then we talk about the motion, which is a straight line motion. So we are talking about a point object which is moving in a straight line, either in one direction or in the reverse direction. So then we have to ascribe a frame of reference to it. So then let us start what we can do. So let us start. So let us say an object is moving in a straight line. So we have a line here and an object is moving in that line. So it can either move in this direction, that is towards the left, or it can move towards the right. So it can move either way. And so we first of all ascribe the origin of our frame of reference. So this origin that we ascribe is the origin where we are standing and observing the motion. And that is the 0 point or the initial state. Now an object which is placed here at time t is equal to 0. Now after a certain time, either it can move here in this direction. So you can say it has moved 4 units. So it has moved plus 4 units. Or it can move here in this direction. So let us say it can move approximately, let us say 5 units here. So we say it has moved minus 5 units because it is moving towards the left. So in each case, either it is moving towards the east or towards the west. In each case, we have to ascribe a sign to the motion, either whether it is moving towards the right or towards the left. So this whole straight line with an origin, with an observer at an origin, that is a one-dimensional frame of reference for a uniform motion in one dimension. So you can understand we have to have, when we are talking about a motion in straight line, we draw a straight line and we mark the origin in that straight line, and then we draw different points or different points of position on that straight line, and that straight line has either one direction which is called positive and the other direction, the opposite direction, is the negative, and the whole straight line is stretching from plus infinity to minus infinity. So and then we can say the position of an object with our frame of reference can be either 5 units or 10 units or 50 units or minus 50 units or minus 35 units or whatever. So this is how we describe a frame of reference for a one-dimensional motion. So let us proceed from here. So when we're talking about the frames of reference, as I've already told you, any kind of motion is inherently relative. So you require a frame of reference. So it can drastically change from one point of view to the other, as I've already told you. So basically, I've already covered this thing. And then let us say when we're talking about motion in higher dimension, like 2 dimension or 3 dimension, then of course, let us say if you throw a stone upwards, for you it is 1 dimensional motion. The stone moves upwards and then comes down. Whereas for a person who's on a train, what will he see? He will see the object is undergoing a parabolic path. So for him, it's a motion in 2 dimensions. It is not only moving across the y direction, but it is also moving across the x direction. So it's a 2 dimensional motion. So that is what the other person who's moving with respect to me will see. So for me, it's a 1 dimensional motion. For other person who's moving with respect to me, a throw of a stone would be a 2 dimensional motion. And it will be completely different from my observation. So neither one of them is wrong. They are simply describing the motion from a different perspective. So this profound principle of physics is called what is called the principle of relativity. The system or the process is the same. The physical world is the same. It's the observer which is observing the thing in a different way. Okay, so there is an ambiguity only in the frame of reference. The physical system evolves independent of the frame of reference, but the frame of reference is important to describe that event or that process, and that is a relative thing. For each person, the frame of reference is different, and so for us, every observation is a relative observation. It is associated with a frame of reference. So as I've already told you, we have to define the 0 point of the origin of our reference frame. As I've already, for a 1 dimensional motion, I've already told you a frame of reference with 1 dimensional motion would be a straight line with a 0 point at the center where the observer is sitting. And so after that, the choice of whether the origin is entirely arbitrary to us. We can choose it anywhere because the straight line is stretching from plus infinity to minus infinity. So we can choose the origin anywhere, but once we have chosen that origin, we have to be consistent throughout. So whenever we have chosen the origin for every kind of reading that we are taking, we have to be, the origin is fixed for that, for us. Because if we want to compare two readings, we have to compare the two readings with a fixed origin, which is not changing. Okay, so the origin can be anything, as I put it in this PPT. It can be a building, a base of a building, or you can say it is a start line of a race, or it can be, let us say, when you are using some laboratory and measuring the length, so it can be a scale. The origin of that scale can be 0 marker on that scale, and so on. So these kind of things can be there. So after that, when we have fixed the origin, then we pinpoint the position. And we then, the position is always in 1 dimension, ascribed a variable x. The position is always ascribed a variable x. So x is the variable ascribed to the position of, let us say, an object. And that is the distance of that object from the origin. Okay. So, for example, if the x is plus 20 meters, then you can say that the object is 20 meters away from the origin towards the east. And if it is minus 15, so you can say it is minus 15 meters, so it is minus 15 meters away from the origin towards the west. So this is how we ascribe the position. So here in this example, if I draw, so we have a a straight line here, and here is the origin, and then plus 20 would be here. So the object is at plus 20 meters here, or the object can be at minus 15 meters here, or it can be anywhere. So this is the position of x. So x is equal to minus 15 meters here, and x is equal to plus 20 meters here. So this is how you do it. Now let us talk about two different quantities which are called scalars and vectors. So in the physical world, there are two quantities that we always think about, and they are the scalars and the vectors. So what is a scalar? A scalar is a quantity that has got both magnitude, which has got only magnitude but no direction. For example, the temperature of the room around us, or the density of a given body, or the mass of a given body, or let us say the time period that somebody takes to cover a particular distance. So all these quantities are scalar quantities because they do not require any directional uh, information. So basically they only require the magnitude. The number is there, it is either 10 seconds or 50 grams or whatever, but there is no, what you can say, reference to the direction. Whereas for a vector quantity, let us say for example, the you can say here the position, either it is in the east direction or on the west direction. So in both the cases, the position is there, but also there is a sign associated with it. So in one dimension, the position or the displacement becomes a vector quantity. Similarly, the velocity, that is the object moving in a certain direction. So not only what is the speed of that object, but also the direction of that motion is also very important. So velocity contains both the speed as well as direction. So velocity is a vector quantity. So you can say scalars are only magnitude and vectors are magnitude and direction. So for example, a 2 kilogram or 5 minutes of volume of an object or energy of an object, these are all scalar quantities. Whereas force, that is if you are applying some force on an object, that force requires a magnitude. How much is the force you are applying? And also a direction, in which direction you are applying. Either you are applying it downwards, or you applying it forward, or you are applying it at an angle somewhere. In each case, the direction of the force is also very important. So all these things like force or momentum or acceleration or velocity or displacement, all of them are vector quantities. So now a very important thing that we talk about is the journey and the result. That is the distance and the displacement. There is a difference between the distance and the displacement. So let us talk about what the distinction between scalar and vectors becomes very important, immediately apparent when we are talking about, we are measuring up the position, whether it is displacement or distance. So these two are different quantities. Distance is different from displacement. So basically distance is just the scalar quantity and displacement is a vector quantity. So distance is basically how much progress in the position that you have, the total path length that you have covered, that is called the distance. So the total path length any object covers, that it would be called a distance. So for example, a person moves around a track, a circular track, and around that circular track, he moves from the initial position to the final position, which is again the same as the initial position. So the distance he has covered is equal to the circumference of the track. So distance is the circumference. Whereas what is the displacement? He has not displaced himself anything. Whatever it was his initial position, the same is his final position. So the displacement is zero in that case. So basically he has not displaced throughout the motion. He has remained at the same point after the motion is completed. So the displacement, the net displacement is zero after the completion of the motion, but he has covered a distance. So distance is a scalar quantity, whereas the displacement is not a scalar quantity, and the displacement is delta x. So basically it's a vector quantity and it's the final position minus the initial position. So for example, if an object moves like this, so for example, you have a straight line and you are at this point 0. So an object comes here, which starts at the 0 and then moves, let us say, 50 meters, and then turns back and moves to the position which is marked as 20 meters. So what is the distance that he has covered and what is the displacement? So the distance is basically 50 plus 20. So distance is 50 meters plus 20 meters, which is equal, rather 30 meters. So he's at position 20. So he has gone back from 50 to 20. So it is 30. This distance is 30. So it is 30 meters. So the total distance he has covered is 50 plus 30, which is equal to 70 meters. But what is the displacement? The displacement is his initial position was 0 and its final position is 20. So the displacement is which is delta x is equal to final position which is 20 meters minus the initial position which is 0 meters. So its displacement is only 20 meters. So simply stated, there is a huge difference between the distance and the displacement. So the distance is 17 meters that he has covered, whereas the displacement, which is a vector quantity, is plus 20 actually. And this plus 20 meters is the displacement that he's having, and that is actually in the east direction. So the plus signifies that it is moving in the east direction. So it's a vector quantity. The plus and minus actually tells you whether it is it is the vector quantity or a scalar quantity. A scalar quantity will never have a sign, whereas a vector quantity would have a sign in one dimension. Okay, so this is about displacement and distance. So here is an example that I've already told you. So an athlete takes a single lap around for 400 meters. So 400-meter track is there, which is a circular lap. And so the distance he has traveled is 400 meters, whereas its displacement is 0. Her displacement is 0 because the initial position is equal to the final position. So the displacement is 0. Similarly, how fast and what and where, that is also an important thing. So basically, how fast will only tell you the speed, whereas fast and where, these two things are going to tell you what the velocity of that object is. So speed is a scalar quantity, and that describes how fast an object is moving. Basically, the reading that you get on the speedometer of your car is the speed. It is not telling you in which direction the car is moving, but it is telling you how fast that car is moving. So that is a what you call a scalar quantity. Speed is the scalar, but a vector quantity is the velocity. So the car is actually traveling in a certain direction. So that direction can be either east, west, north, south, or wherever. Okay, something like northwest, or that direction is also there associated with that quantity, so that the car actually has a velocity as a vector quantity. In one dimensional motion, displacement is a vector quantity, whereas distance is just a scalar quantity. So here is a table, scalar versus vector quantity in motion. So the definition of the scalar is a quantity described by magnitude only. Vector, a quantity described by both magnitude and direction. Examples are distance, the total path length traveled, and the example for vector quantity is displacement, the change in the position from the start to the end. Similarly, speed, the rate of change of distance. So speed is defined as the rate of change of distance. whereas velocity is the rate of change of displacement. So we will describe it a little later. We will describe it in form of certain formulae. So it's the difference between speed and velocity is in the definition itself. Okay, then the direction is also not included. So direction is not included in speed when you're talking about speed, and the direction is included when you're talking about velocity. And similarly, the calculation is basically a distance would be sum of all the lengths of all the path segments, and the displacement would be x initial minus x final. So that would be the difference between displacement between distance and displacement.